Hello everyone, welcome again. In the previous video, we have created a custom shape to create the footprint of this transistor. We created this big source pad. We have not created the pad yet, we just created the shape symbol that is required to create the pad. Now in this video, we are going to create the pad by using the shape that we have already created. Besides that, we are also going to create these standard pads, and finally we will be using all these pads to create this PCB footprint. Okay, let's create this drain pad first. To create this pad, we have to open up pad designer, and I already opened up my pad designer, and here you can select different units. I prefer to work with mils, so I will select mils, and here in this drill parameters, you have to make sure that the drill diameter is 0, because we are going to create an assembly footprint. We don't want any drill hole in the pad. Now, after setting up these parameters, go to layers and select, make sure to select single layer mode. You have to select the single layer mode for assembly footprint. Now select begin layer, go down to the geometry tab. Here we have to select rectangle because this shape is rectangular, and the dimension of this shape is given here, which is 310 mils by 39 mils. I'm going to input that information here, 310 and 39. Okay, now we have to also create the solder mask top layer. The solder mask layer needs to be a little bit larger than the actual pad, so I will add 10 mils more than the actual pad. 320, I will make it 320, and this one I will make 49. Okay, so you can see the top view of the pad that we just created. We have not saved it yet, but you can see the shape is pretty similar as shown in the datasheet. Okay, let's save this pad as GS66516 drain. Okay, so I have created this pad once before. That's why I see the name in my custom library folder. So what I will do, I will just replace the existing file with the new one. Okay. Now let's create this small square pad. The dimension of this pad is given here, which is 39 mils by 39 mils. So I will just edit the parameter. If I select begin layer, I can select rectangle or square, it doesn't matter, it's the same. Then I have to select solder mask top. As I said before, I will add 10 mils, so I will make it 49, and the height is already 49 mils. Okay, now you can see the shape is also looks similar to the shape that is given in the datasheet. Now I'm going to save this as GS66516 gate. As I said before, I have created these pads before once, so I am going to override the existing file. Okay, we are done with this drain pad and the small source and gate pads. Now we have to create the big non-standard pad using the shape that we have just created. To do that, again, I'm selecting begin layer. In the geometry box, instead of selecting these standard shapes, we have to select shape. And when we do that, we have the option to select the shape that we have just created. So if you click here, this window will pop up, and you will see the shape that you have just created here. Not yet, because we have just created the shape, but the pad designer tool does not know where we put the files. Now what we have to do, we have to copy those shape files, we have created two shape files, right? One is .dra and another is .ssm. So basically we have to copy those two files and put it in the symbol folder where Orcad puts all the symbols. Okay, I will show you the directory of that folder. Now let's copy the files that we have just created. So it's in the custom library folder. You know where you saved your files, and I know where I set my files. So the shapes, one is this shape.ssm and another will be shape.dra. So I'm going to copy these two files and I have to copy these two files in the cadence symbol folder, right? So find this cadence folder in your computer and go to SPB 16.6. This number might be different in your case if you have different version of Orcad. So if you go inside this folder, you will find this share folder. Go inside the share folder and then go to PCB folder here. Inside this PCB folder, there is a folder that is PCB library folder, and inside that folder you will find the symbol folder. So look into this directory. You can make a note of this directory for your future reference, or you can just save this video. Now I just have to paste the files that I just copied. Okay, now let's go back to Pad Designer and see what we have there. So the files are still not here. So let's try to okay, so I closed that pop-up window and opened again, and now I can see the shape that we just created. Okay, select the shape and you can see the shape here. Okay, click OK and it already fills these dimensions boxes. Okay, now let's go to Solar Mask top option, and here I'm going to select the same shape. Now earlier I had told that the Solar Mask dimension should be a little bit larger than the actual pad. So you have to create another shape in the same way that I have created the shape for the source pad, but it needs to be a little bit larger. So you can add 5 mils on each side of that shape. But for this example, I'm just going to use the same shape. Okay, this shape, and I've selected that and it's done. I'm going to save this path as source gs66516 source. Okay, saved. So I saved it. Now all the paths are created. Now what we have to do, we just have to create the footprint. To create the footprint, we have to open up PCB editor. We have to create a package symbol first. So go to File and select New. Drawing type will be package symbol, and here the name of the footprint. You have to browse the folder where you want to save the footprint. I'm going to select my custom library folder. Okay. Now I'm going to turn on the grids. Now if you go to setup and select design parameters, And if you go to this design tab, here you will find this extends information. So this is basically dimension of the canvas. So we have 21,000 mils in width and 17,000 mils in height. So basically this is 21 inch by 17 inch. And left coordinate, so left x, that means x coordinate of the left corner is 0. So this side, it starts, the dimension starts from this side, and lower y coordinate is 0. So left x coordinate is 0, lower y is 0. Basically this point is the origin. Now we want to move this origin somewhere in the middle, because if we don't move the origin, it will create some issue to if we want to put some pads in a negative coordinate. So if let's have a look in the PCB footprint in the datasheet. So if you see, their origin is here, and this pad is on the negative coordinate on the left side. So, and it is also lower than the origin. So both x and y coordinate for this pad will be negative. Now, if our origin is on the lower left corner, we don't have any option to put negative coordinates. That's why I want to move this origin to somewhere in the middle. Okay, so to do that, what I will do, I will just make it 2000 minus 2 inches, and I will do the same for y. And I don't need this large canvas, so I will just make it 4000 and also 4000, and I will apply the chains and close this window. Now you see the origin is in the middle. Okay, now let's put this first pin on our canvas. So this is the drain pin, and we already have created this pad. To place the pin, we have to go to layout and select pins. So you will see this window. If you cannot see this window, basically in that case, it will be okay. I closed that window accidentally. Okay, so if you ever do that, so you can get that back from view, windows, and select options here. Okay, so sometimes it might be hidden like this, so you have to click this option tab and it will come in front. And I want to pin this here so that I don't need to bring it back again and again. Okay, here in this pad stack option, we have to select the pad stack. So let's select the pad that we created. So it's started with Z. So this is the drain pad that we just collected. So this is the drain pad that we just created. So select this drain pad. Now here pin number is 1. Everything is fine. Let's place at the right coordinate that it needs to be. This drain pad is at a distance d from the origin. So let's see the dimension of d. So this is 155 mils. So the coordinate of this drain pad will be 0 and 155. So I will go to that coordinate. So x 0 155. So it's placed where it is supposed to be. Okay. Now let's put pin number 2 and 3. So pin number 2 and 3, the pad will be the gate pad that we designed. That is this one. Select this one. Pin number is 2. Now the coordinate for this pad will be the x coordinate. Let's find the x coordinate first. The x coordinate is the distance of this pad from the origin, which is equal to f. So this f is basically 194 mils. And y coordinate will be minus h. So a is also given, which is 96. Therefore, this is going to x minus 194 and minus 96. So pin number 2 is placed. Now it's time to place pin number 3. For pin number 3, we don't have to change the paths. Now pin number is automatically incremented, but if it is not, manually change the pin number. The x coordinate of this pin is same as before, but the y coordinate is equal to minus g, which is 155 mils, negative obviously. So let's place this pin x minus 194, y coordinate will be minus 155. Okay, we placed that pin as well. Now it's time to place pin number 4. Okay, let's place pin number 4 at the end. Let's place this pin number 5 and 6. So now this is pin number 4. I will manually change it to pin number 5. And this is pin number 5. So the coordinate will be exactly similar to the one that we just placed before, but it will be, the x coordinate will be positive 194 and y coordinate will be minus 155. So we have placed this here. We have to place pin number 6. X coordinate will be 194. Y coordinate is minus 96. Okay. Now we have to place this big pad. We have to change the pad here again. So let's select the pad that we just created, and this is source, this pad. Okay. Now the pin number is 4, and so you can see the path. We have to find out the coordinate for this path. So the coordinate will be, so it has this dimension small e. So this is the coordinate for this big path. So e is 73 mils. So it will be, x coordinate will be 0 and y coordinate will be minus 73. Is a mistake. So okay, I think I know what we have done wrong. Basically, when we created the shape, our origin was this point, if you remember. So we have to find the dimension based on this point, which is going to be a little bit complex than we thought. We know the length of this edge of this source pad is the length of B2 plus length of B1 plus length of B2 again, which is 428. Now, as the origin is in the center, so we can just divide that by 2 to find the x coordinate of this point. If we do that, we get 214. So we know the x coordinate of this point is 214. Now we need to find out the y coordinate of this point. And we know the distance of this point to the origin is given by E, which is 73 mils. So if it is 73 and half of the height is 102, so we can just find the y coordinate by subtracting this portion, that is 73, from 102. So I'm going to do that, and I get 29. So the y coordinate of this point will be 29. So now let's select, right click here and select oops, so it will be unplaced, and we can put the coordinate again. So the coordinate will be, x will be minus 214, y coordinate will be positive 29. Now it's in the right place. Okay, so right click and it's done. Okay, so we have placed all the paths. Now the PCB footprint is almost finished. We only have a few things to do. So go to layout and select labels and reference designator. Here I'm going to select silk screen top. So basically this portion will be on the silk screen, this text what I am going to put now. And you can still change the text block size. I will select 2 and I will write here. So I want to put Q and star. The star mark is for the numbers that is going to indicate the component. So right click and click done. Now I also want to put an outline for this footprint. So I'm going to select this rectangle shape add option, and I'm going to select package geometry here, this one, and I will select silk screen top, and I will change this type to unfilled. So static solid means it will be covered by the silk screen. I don't want this whole footprint covered by some paint. I just want to show the boundary. So I will select place rectangle, and the dimension will be here. Let's see if it is here. So I can find the dimension from here. Okay, so it's given here A by B, and A is 434 mils, B is 355. So it will be 434 mils. Height is equal to B 355 mils. We need to find the coordinate of this point to place this shape in the right place. To do that, we just have to divide the dimensions by half and use that information. So if we do that, we will get 217 in the x coordinate, and it is negative 217. The y coordinate will be 355 divided by 2, which is 177.5. 177.5. Okay, so it's placed in the right place. Now it's done, and we have to save this file. Okay, so I've saved this footprint, and you will see in the command window that will show you that the file, the PCB footprint, has been successfully created. So it will create 2 files. One is .dra and another is .psm. Congratulations, you have learned how to create a custom PCB footprint, even using a custom non-standard shape. Thank you very much. Goodbye.